All right, in this question we need to prove a reduction formula for the power of natural logarithm x. And then we'll use that reduction formula to evaluate the cube of the natural logarithm. So let's see how this goes. Let's start off by just recopying the integral we need to evaluate. To do this, we're going to use integration by parts. And it may not be totally clear of what u and dv are going to be, but it's this trick where we kind of multiply by 1, and we've done that before. So here's the formula for integration by parts. We'll write down our usual little table here. So u is going to be ln x to the power of n. And dv is just going to be 1 dx. In other words, dv is dx. What's the antiderivative of 1? It's x, right? And what's the derivative of ln x to the n? Well, by the chain rule, the n comes to the front. We have ln x to the n minus 1. And then we multiply by the derivative of ln x, which is 1 over x. And then I have to write dx. I need a little bit more space here. So like I said, we need to have a dx on the end there. Okay, so that's everything set up for integration by parts. Let's see what happens. We have to start off with u times v. So here's u and here's v. So it's ln x to the power of n times x. How about I write it in the other order, though? Let me put the x first. It looks a little bit better. uv or vu, it doesn't matter. So ln x to the power of n minus the integral of v, which is x, du, which is all of this stuff. So times n times ln x to the n minus 1 times 1 over x dx. And this part's looking good, right? That's matching what we're supposed to get. How about over here? Well, notice that this x and this x, they actually cancel. And this n can be brought to the front. And it looks like we obtain exactly what we want. So we've just proven this formula here matches exactly with what's right here, right? That's what we needed to prove. So we're done. So how do we apply the answer for part A? How do we apply this reduction formula to actually evaluate the cube, the integral of the cube of ln x? So let's see how that goes. Move that up a little bit. So let me copy down the question. What I'm going to do here is, instead of writing these brackets, I'm just going to put the 3 above the n. That's the same thing, right? It looks, it'll look a little bit nicer to work with that, so we don't have to write so many brackets. But it's the same thing. So really, to get started here, we're going to start, this integral is the same as this integral when n is 3. So we're going to put n to be 3 in here. And actually, I'm not going to use brackets there either. Just to, I think it'll look better. So n is 3 in this formula right now. So x, ln cubed x, minus 3 integral 3 minus 1, 2, so ln squared x dx. Good. Now, actually, I'm not even going to write that integral sign, because to do the integral of ln squared, I go back to my reduction formula, but this time n is 2 now. So the integral of ln squared is x ln squared minus 2, because n is 2 right now, integral of ln x. 2 minus 1 is 1, so that's just a 1 there, dx. So there we are so far. Let's keep going. I need to clean this up, so I'm going to recopy x ln cubed x. This 3 I'm going to distribute across. So it would be minus 3x ln squared x plus 6 integral of ln x dx. And now we're going to apply the formula one more time. But this time, the power here is 1, right? So it's like the power is 1, so I'm going to be looking right here and replacing all the occurrences of n by 1. So what do we get? I'll just recopy this part. 6, big bracket. So x, ln x to the 1, which is just x ln x, minus n is 1, so that doesn't do anything. N is 1, so 1 minus 1 is 0, so we have ln x to the 0, which is 1. So this is really just the integral of 1 right here. And that's easy, so we're very much nearing the end right now. And let's see. How do we finish this off? Well, this 6 can be multiplied across, so we'd have 6x ln x. What's the integral of 1? It's x, right? So this is really minus x. And 6 times that, so it'd be minus 6x. And then we just have to remember to put a constant on because it's a indefinite integral. And so there we go. So we just used that reduction formula to evaluate the third power of ln x, the integral of that. And so there we go. That finishes this problem. I just realized I did a silly little mistake here. This shouldn't be ln squared and then nothing and then plus x, right? This plus sign should not be there. So we should just put an x there and make this a little bit nicer by putting the plus there. And now we're okay. So that's going to be our final answer there, okay?